In this video, we are going to look at an example of related rates. So let's jump right in. Here we have a spherical balloon is being inflated with gas at a rate of 800 cubic centimeters per minute. So it's being inflated at some rate. How fast is the radius of the balloon increasing when the radius is 30 centimeters? So let's first draw a picture of this situation. So this situation, we have a spherical balloon. Right? So it's a sphere. We know it's being filled with gas at some rate. And there is some radius r. And that's about all we can do here. Now let's write an equation that relates our two variables. Right? So an equation that relates the volume to the radius. So how are volume and radius related? Well, for a sphere, the volume is 4/3 pi r cubed. Are either one of those fixed values? So can I plug in, so we see a radius is 30, can I plug in that value 30 here right now? The answer is no, because that radius is not a fixed value. As we continue to add air into this balloon, that radius is going to get larger and larger and larger, right? So that radius is not fixed. We can't plug in this value, even though we're going to plug in a value of 30 later on. We can't do this yet. Now what? Now we want to take the derivative of both sides with respect to t, with respect to time. So on the left-hand side, our derivative dv is dv dt. On the right-hand side, we are going to take our derivative. So the derivative of r cubed is going to be 3r squared dr dt. That 3 times the 4/3, we will get 4 pi r squared dr dt. So that is our derivative of both the left and right-hand side. Now, what else do we know about this situation? Now we're going to plug in values. So we want to know when the radius is 30. So we're going to plug in r is equal to 30. What is the rate that the volume is changing? So we're trying to figure out what is dr dt. Do we know dv dt? So the change in volume with respect to time. Well, that was given up here. That was the 800. So dv dt is 800. Is that volume increasing or decreasing? So is this positive 800 or negative 800? Well, this is going to be a positive 800 because our balloon is being inflated, so that volume is going up, it's not going down. So if they told me it was deflating with a rate of 800 cubic centimeters per minute, then this would have been a negative value instead of positive. But it's inflating, the volume is increasing. And we're going to just plug those values into our derivative. And so 800 is equal to 4 pi times 30 squared dr dt. We're going to solve this for dr dt. And when we do that, we get dr dt is 800 over 3200 pi, which is 0.707. And what are the units on this? Well, the volume was in cubic centimeters. Our radius then is in centimeters, so it's changing at 0.707 centimeters per. And what are the units of time? This was an increasing per minute, so this is also per minute. So our change in the radius is 0.707 centimeters per minute. And there we have solved another related rates problem. Come back for the next video where we look at another setting where we have related rates. With related rates, each one of them is subtly different, but the problem-solving process is the same. We are looking for what is a function that relates the variables, those unknown variables. We take our derivative implicitly, we plug in the known values, and we solve for the rate that we're interested in. All right, we will see you in our next video.